So is the AI hype actually real? I mean, we hear all this stuff, these incredible advances. Are we, really on the verge of something huge like exponential growth changing everything?
Or is it just another tech bubble, maybe?
Exactly. Is it about to just fizzle out? That's really the big question we're digging into today on the deep dive.
Hmm.
We've got some pretty interesting source material here, particularly looking at this question. Is AI booming exponentially?
Yeah, it's a good piece.
And our mission today, it's pretty straightforward.
Yeah.
Let's unpack what's really driving AI right now and figure out if it truly counts as, exponential.
Okay, let's do it. It's definitely a question worth dissecting
For sure.
because the sheer amount of news, I mean, it can feel a bit much, right?
Mm-hmm.
Trying to sort out the real progress from maybe inflated claims.
Really.
And as our source material points out, a good starting point, kind of the foundation for understanding this growth, or at least how it started, is Moore's Law. Many people have probably heard of it.
Right, Moore's Law. Yeah. And maybe just a quick refresher for anyone listening who isn't, completely steeped in tech stuff. It's not like a law of physics, right? It's more an observation, a trend.
Exactly. A very powerful trend,
For
though.
decades, it basically said the number of transistors you can fit on a chip roughly doubles every 2 years, give or take.
Hmm.
So how did that really set the stage for the AI we're seeing now?
Well, it's pretty direct, actually. More transistors squeezed onto a chip just means more processing power.
Okay.
And that power is absolutely essential for running the kind of complex calculations, the algorithms that modern AI relies on.
So it's like constantly getting a faster engine for our computers.
Yeah, think of it that way,
Right.
allowing them to tackle much, much harder problems. And the source makes a good point about the graphs, too.
Oh yeah, the logarithmic scale.
Right. When you plot Moore's law or any exponential growth on a graph with a logarithmic y-axis, it looks like a straight line just shooting upwards.
Which really highlights how fast things are accelerating, even if it looks linear on that kind of chart.
Precisely. It puts that speed into perspective.
But here's the thing, the material we're looking at, it really stresses that, okay, Moore's law kicked things off, gave AI that initial boost,
Hmm.
but the current boom, it's being pushed by a whole lot of other things that are really kicking in now.
That's the key point now, yeah.
So let's get into those. First one, just raw computational power increases. It's not just about more transistors on the same kind of chip anymore, is it?
No, not at all. Moore's law was, like you said, the catalyst, but then we saw this huge leap with specialized processors, hardware designed specifically for AI jobs.
Like GPUs,
Yeah.
graphics cards.
Exactly. GPUs were first made for, video games, rendering images, but it turned out they were amazing at the kind of parallel math AI needs.
Huh, interesting.
And then you get things like TPUs, tensor processing units. Google developed those, custom built to just crunch the specific kinds of matrix math that are like the absolute core of a lot of machine learning.
So they optimize just for AI tasks.
Right. It's fascinating because the old general purpose CPUs just weren't cutting it as the AI models got bigger and more complex. That limitation actually spurred the invention of these new architectures.
So we went from the standard car engine to like a specialized Formula One engine just for AI.
That's a great analogy, yeah.
Okay, so better engines. What about the fuel? The next big factor mentioned is just the incredible amount of data available. Feels like we're swimming in it.
Oh, absolutely drowning in it.
Right.
And that data explosion from the internet, social media, all our phones and devices, it's been completely crucial.
How so?
Well, machine learning models, especially the deep learning ones we'll talk about, they learn by seeing examples, millions, billions of examples.
Yeah.
The more data they chew through, the better they get at spotting tiny patterns, making predictions, getting more accurate. This big data is basically the training school for AI.
Got it. So the more info they get, the smarter they get. It's this feedback loop,
Exactly, a powerful improvement cycle.
which makes sense. Okay, then there's the algorithms themselves, the actual intelligence part. This feels like where some of the really mind-bending progress is happening.
Definitely. As the source notes, machine learning is, a type of AI.
Yeah.
And within that, deep learning has been just revolutionary.
How does deep learning differ?
It uses layers, multiple layers, to learn increasingly complex features from the data. Think about how a kid learns to recognize a cat. First, maybe simple shapes, then fur texture, then pointy ears, building up.
Oh, okay. Layers of understanding.
Right. And that ability has led to these huge jumps in things like recognizing images, understanding language,
Yeah.
stuff that used to be purely human territory.
It's like they went from basic matching to almost understanding concepts in a really short time.
It feels that way sometimes, yeah.
And it's not just the tech getting smarter. The source also flags the huge surge in investment, money and research pouring into AI.
Oh, massive amounts. You've got private companies, big tech, venture capital, and governments, public research funding.
Hmm.
It all signals this widespread belief that AI is going to be transformative.
And that money obviously helps speed things up.
Hugely. It funds bigger projects, attracts the best researchers, and just accelerates the whole cycle of research, development, and innovation. You get promising results, that attracts more money, which leads to even better results.
Another feedback loop.
Exactly.
And it feels like it's not just the usual big players anymore. The source talks about the democratization of AI,
Yeah, that's a really important point.
meaning it's easier for more people to get involved.
Precisely. You have these powerful open source tools now, frameworks like TensorFlow, PyTorch.
Heard of those?
They basically give developers pre-built blocks, lots of help guides, user-friendly ways to build and test pretty sophisticated AI models.
So you don't need a giant corporate lab anymore.
Well, maybe not for everything. It means researchers, smaller companies, even students or hobbyists can contribute.
Right.
You get more people, more different ideas tackling the problems.
Which logically leads to faster progress, more innovation.
Definitely. A richer ecosystem.
Okay, and one more factor mentioned is this idea of interdisciplinary integration, AI working with other fields.
Yes, this is fascinating. You take AI's pattern-finding power and combine it with deep knowledge from, say, biology or physics or medicine, even psychology.
How does that help?
Well, you can create these hybrid models. AI could analyze massive amounts of genetic data to help find new drugs faster, for example. Or model super complex physical simulations. It's about synergy. The combination is often way more powerful than either field alone.
Wow, okay, so let's recap. We've got faster specialized chips, unbelievable amounts of data,
Yep.
smarter layered algorithms,
Right.
a fire hose of investment,
Billions.
tools that more people can use,
Mm-hmm.
and AI teaming up with other sciences. It really does sound like, well, like all the ingredients for extremely rapid change are coming together at once.
And the source emphasizes that positive feedback loop again. Progress in one area, say better algorithms, lets us use the existing hardware more efficiently to process more data, which leads to better algorithms again.
It all connects and pushes everything else forward faster.
That interconnectedness, that synergy, that's what makes this feel different. It's driving this acceleration we're seeing.
Okay, so we've kind of laid out the why, but then the source hits us with this pretty staggering statistic. Since 2012, AI computing power needed for training has been doubling roughly every 3.4 months.
Yeah, months, not years.
That's way faster than Moore's law, which was doubling every couple of years. The source explicitly says this rate exceeds Moore's law.
It completely blows past it. And that stat really hammers home the point that the main engine of AI progress isn't just about silicon improvement anymore.
Right.
This incredible surge in compute power is what's enabling these massive, complex AI models we're seeing.
Yeah.
That unlocks things that were just, well, science fiction not that long ago.
Think about that speed, 3.4 months. Things we see now could be totally different by, like, next season.
It's a mind-boggling pace, really.
And it's not just theory, right? The material mentions a chart showing AI models hitting and sometimes beating human performance on specific tasks.
That's right. Tangible results. We're seeing it in image recognition. AI is often better than humans now. Complex games like Go or chess.
Yeah, they conquered those ages ago, feels like.
And even in some aspects of understanding language. Now, it's key to say this doesn't mean AI is smarter than humans overall. Not even close.
Right, it's specific skills.
Exactly. But it shows how quickly they're improving in these defined areas. It's a direct result of all that compute power and those better algorithms.
It really gives you this feeling of momentum, like we're on a path somewhere. The source talked about stages of AI development, right? ANI, AGI, ASI. What are those again?
Sure. So ANI is artificial narrow intelligence.
Right.
That's what we mostly have now. AI that's really good at one specific thing.
Like playing chess or recommending videos.
Perfect examples. Then there's AGI, artificial general intelligence. That's the hypothetical stage where AI has human-like cognitive abilities across the board. Learning, reasoning, adapting like a person.
The kind you see in movies, maybe?
Kind of, yeah. Then ASI is artificial superintelligence. That's AI surpassing human intelligence in basically all aspects.
Okay, it's scary now.
And then there's even AUI, artificial universal intelligence, which is even more theoretical beyond ASI.
So where are we now, according to the source?
It suggests we're firmly in the late stages of ANI, the narrow stuff, but maybe seeing some early glimmers, some characteristics that could point towards AGI in certain limited ways.
Okay, so AGI isn't here, but the path seems to be heading that way and maybe faster than we thought.
The trajectory is certainly steep.
But the source does add a note of caution, right? It briefly touches on challenges, downsides.
Absolutely, and we shouldn't gloss over those.
Things like ethics, jobs, security.
Right. While the potential upsides are huge, we absolutely have to grapple with the societal shifts, the ethical questions, making sure this powerful tech is developed and used responsibly. That's a whole other deep dive, probably.
Definitely. Okay, so let's try and wrap this up. Going back to our first question. Is the AI hype real? It really sounds like the answer is yes. And the exponential part seems pretty justified too.
I think that's fair. It's not just one thing. It's this combination: hardware, data, algorithms, investment, access, collaboration, all feeding each other.
And it's pushing AI capabilities forward at a speed that's outpaced traditional tech improvement, like Moore's Law.
Yeah, Moore's Law was the starting block, but AI is running a much faster race now. And we're seeing the results in AI matching or exceeding human skills in more and more narrow areas.
And we're moving through those stages, AI, towards potentially AGI, faster than maybe anyone predicted.
The progress is undeniable.
This has been really, really insightful. So, given this speed, this acceleration we've talked about, it makes you wonder, doesn't it? What are the big shifts you think we might see coming soon? Not just in tech itself, but like in society.
Hmm.
How might our work, our lives, our communities fundamentally change because of this? That's definitely something to chew on.